Have you ever wondered how camera flashes work? It works due to a small component called capacitors. These capacitors can store a large amount of electrical energy and release it instantly. So to understand capacitor, let's take two conductors. These conductors on its own doesn't have anything peculiar happening about it. There is no charge accumulation, there is no current, there is no potential difference, nothing is happening here. So what we'll do? We'll try to add a potential difference. And how can we add a potential difference? We can add a potential difference by connecting a battery to it. Now let's try to understand how a battery affects a system. For that, we'll remove these plates and put a bulb there. When a bulb is connected to a battery, the battery provides a potential difference which makes the charge move throughout the circuit. This flow of charge is what we call as electrical current. And as the current goes through the bulb starts to glow. Similarly, in our case also, when the potential difference is added to this system, the charge starts to flow. But as soon as it reaches a plate, it cannot go anywhere else because there is a gap between these plates. So the charges will start to accumulate in one plate. And as you can see, there will be a lot of small positive charges in this plate. And the effective charge of this plate will be positive, and let's call it as plus Q. And the effective charge of the second plate will be negative, and let's call it as minus Q. And this system is what we call as capacitor. So capacitor actually consists of two conductors separated by a distance and has equal and opposite charges. Let's go back to our initial case. In the initial case, there was no charge accumulation as there is no potential difference. But when the potential difference is added, the charge starts to accumulate. So we can say that Q is directly proportional to V. And to remove that proportionality sign, we can add a proportionality constant. Then our equation becomes Q equal to C times V. And this equation, Q equal to CV, C is actually the constant of proportionality. And this constant of proportionality is what we call as capacitance. So capacitance equal to Q by V, that is charge per unit volt. So what does it mean? It means that capacitance actually measures the ability of a capacitor to store the charge. And capacitance is always positive. Now let's try to derive the SI unit of capacitance. For that, we'll use this equation, C equal to Q by V. Now what is the SI unit of Q? It is coulomb. What is the SI unit of V? It's volt. So the SI unit of capacitance will be coulomb per volt. So instead of saying coulomb per volt all the time, we have given it a different name, which is farad. So SI unit of capacitance is farad. So what are the factors that are affecting the capacitance? First is size. To understand that, we take two capacitors. Capacitor A, which has a small plate, and hence we can see that the charge that can be accumulated in this plate will be much less. Hence the capacitance of capacitor A will be less. And the capacitor B has a larger plate. Hence the amount of charge that can be accumulated in this plate will be much higher. Hence the capacitance value will also be high. Next factor is shape. Different shapes can accumulate different amount of charge. Hence the capacitance value of that capacitor will be higher or lower depending upon the amount of charge that it can accumulate. Next is relative positions between the plate. Other is the medium between the plates. So these are the factors that affects the capacitance value of a capacitor. Thank you and have a nice day.